G'day everyone and welcome back to the channel. Alright, so although I had this working, I'm confused. I watched my original video where I went from just a normal input stage to the complementary feedback stage, and then I had the 4 transistor current mirror, and I had 47 ohm resistors on the top, 1K in the middle, and you guessed it, 68 on both sides at the bottom. And it worked. So I've got 2 theories. Theory number 1, or 3 theories actually. Theory 1 is maybe that the gain's so high that it's just so easy for it to flip sides. Maybe I need to lower the resistors on each side, the 15K resistors, like make them 10K or something, the input to ground and the feedback resistor. Okay, the other thing I've been thinking is maybe it is actually wired up wrong. The other thing I've been thinking is maybe with the beta enhanced transistor and the fast transistor and an output stage, that somehow just makes it work. So the thing I don't get about that is if that was the case, when I hooked my amp up, it should have worked. Well, it didn't. So I'm confused. I'm not going to lie. Now, as it is now, if I turn the power supplies on, 0 offset. Let me go grab 2 1K resistors and 2 68 ohm resistors, rip them out, replace the resistors with the original values, and we'll see what happens. Alright, yeah, I know I did this in the last video, but we're going to take this one step further. Try a few different things. Alright, 1K, 47, 47, and 68 and 68. Alright, I'll turn both the supplies off and turn them on together again so that it gets started up with an equal voltage. Not that it's going to make any difference, but just trying to give it all the chances I can give it. Just double checking my connections are right. Yep, that's how it was. Alright. And straight to the rail. Alright, so what if, without changing the input and the feedback side, what if I just change which transistors are diode connected, if that makes sense? So how would I do this? I believe like that and like that. Top one, not Yeah. Alright, I'm not going to bother turning supplies on and off. Let's see what happens. No, that makes absolutely no difference. It's still stuck at the rail. Wait, what? Is that going to go swing negative, isn't it? I think I know what's going on here. Hold on a sec. Yeah, that ain't slowing down. That's going to go... It'll get to about 2 volts and then it'll just start shooting up 3, 4, 5, 6, 7, 8, 9. By the time it gets to 20, it'll just go bang to the rail. Yep. How did I know? Alright. Well, oh goodness. I don't know what to say. With the capacitor out, no difference. It's a shame. It really is. I just watched my video and it was working perfectly with these values. All I can think of now I really can't be asked to do this, but I'm going to have to, is set up a little output stage. Hook it up to an output stage, hook the feedback up to the output and see what it does then. This is really odd. Really, really odd. I don't know what to say. I'm going to go have a look again, just double check all the connections according to like actual documents on current mirrors and all that sort of stuff. And if it's definitely right, then I guess I'll make an output stage for it. Here's the thing. What I was thinking is if I do have to have, a really low value on one side and a high value resistor on the other, instead of having a short on one side and say 68 ohms and 0 ohms, maybe I'll go 680 ohms and 68 ohms. That way at least I've still got degeneration on both sides. I'm going to have more degeneration on one side than the other. Yeah, there's a lot of questions I have here. I have a feeling when I get the amplifier built, maybe not with the equipment I've got currently, but when I get something like the Quantasylum, I'll be experimenting with this and we might, have some interesting discoveries. We'll at least be able to work out what gives the best performance and what's going on, put it that way. I'm just going to go give this one more check over and I'll come back and tell you what I think. So I was doing some more thinking and what if my power supply rails are not symmetrical? I've never checked. It's not like I set it with a meter. I just turn them up around 30 volts for each rail, all 4 rails. I mean, not that the rails are ever going to be perfect in an amp either, so you can't rely on that, but I'm just curious, is it out by a bit? So 59.72. I don't think that's it. I mean, let's... Alright, 59.72, 59.72. I really don't see this making any difference, but just to do due diligence. Why am I not surprised? Well, now I'm confused because I want to go hook up a little output stage to it, add the feedback loop to it, the gain from the VAS stage, and maybe that closed loop gain's enough to, hold it in the middle and stop this happening. But I really can't be asked. And the other thing is, if it was that simple, then how come the output stage that I've got there, it's not working with? If that was the case, it would just work. Yeah. Quite confusing. I guess we could always power that up, turn that pot all the way down that I've installed, and see, if that stops it. I think I'll just hook up an output stage. I should be able to just use, like, what... I've got to hook up all the current sources on that too. You know what? I'm just going to go back to that, and we'll just see what happens with the pot. If, that doesn't work, then I don't know. Maybe I'll have to hook up an output stage on the breadboard and keep mucking around with it. I'm determined not to lose the current mirror. So that's input, feedback's tied to there. So I'll put my feedback back on the output where it's needed. That is the right output I'm hooked up to, isn't it? Yes. Can you imagine the whole time it was just because I was taking feedback off the other channel's output? God, that would be dumb. Hook my drive back up to the base of the VAS. Audio grounds there, power rails are connected. Let's just hook up bias and base again. So diodes point this way, so this is the NPN side. PNP side. NPN base. PNP base. All right. Get our multimeter. Put that on the output and ground. And that little pot that I've installed over this resistor needs to be turned that way, is shorting the resistor completely. All right. Attaching ground. Am I current limited? I don't think I am. Yeah, hold on a second. Hold on a sec. Yeah, no, I'm not doing that. Alright, I don't have a lot of current, but there is current. I'm going to turn the supplies off too. Oh, and I'll short over some of the diodes on the bias string that way, because I'm current limiting. I don't want any bias right now anyway. I just want to see if I can get the thing to work. I've got 2 diodes on the board. If I short over these 2, that will leave still 4 diodes. Alright. That works. Alright, I'm going to power up and see what happens. And no, we cannot come up. No. There is no way in hell. Goodness. Oh, it's trying to. Let's turn supplies off. I'll give it about half an amp. I'm just going to have to set my supplies. Alright, got half an amp. Let's see what happens on power up now. Yeah, no, half an amp. Still won't do nothing but just swing to one of the rails. In fact, that's trying to take half an amp of current. What the hell? In what? I'll take it the output stage because nothing was warming up. What now? Ah, this is bloody ridiculous. I tell ya. This is sad. I'm going to short over the entire bias, just leaving 2 diodes in there. Let's see if that still takes half an amp. Yep. Wow, that's crazy. I have no idea where the half an amp is going. Oh. Why am I feeling transistors on the wrong side? Oh, what just happened there? Oh. My lead came out. Man, this bloody sucks. You know what I've just realised? You've got to be shitting me. No. The bias is round the wrong way. Oh my god. Whoopsie. The diode should be pointing out of the NPN side because I'm a dumbass sometimes. Okay. I need to turn around 4 diodes and reverse 2 wires. This should work. Let's just... Oh, that is so funny. No wonder the whole time I've been saying it seems like the output stage is trying to just drink excessive current. This is going to be annoying. I'm just going to change these 2 diodes around and change the wires first on just this one channel that we've got powered up or are powering up. You gotta be shitting me. Come on. I'll worry about soldering them in all neatly and all that afterwards. The wire's got to come off there. God, I can't believe I've done that. The last time I built an amp, I put the NPN drive on the PNP and the PNP drive on the NPN. This time I go and put the bloody bias around the wrong way. Just trying to turn the entire output stage on hard. What was I thinking? Or not thinking? Alright, now try this again, because that actually goes there and this goes up here. Dumbest things I've done. God. Alright, I am going to also, what is that, 47k? If I open that pot up all the way, it's basically got no effect. Because I want to see if this can work with 268 ohm resistors like it did when I designed it. Alright, looking at the output again. I'm going to go turn the power on. it's actually come up this time. Wow, with 0 offset, you've got to be shitting me, it works. Only problem is it's pulling half an amp. But it's working, it's just excessive bias current, and I'm pretty sure if I just do this and turn it on again, it won't be pulling half an amp, and that will prove that it's just bias. But as you saw, that was the output to ground, and it had no offset. Yep, now we're only pulling 30 milliamps. Oh, we've still got offset. Oh no. You beauty. Actually, no. Something's not right. I can smell. I swear I could smell something. Don't worry, my eyes are shut, so something pops. No, nothing's burning. I was just tripping balls. Oh, what the hell? Oh no. Okay, sorry, that was just me having a loose connection. I want to get that 47k pot out, so I've got perfectly matched 68 ohm resistors because that's how I designed it, and it's actually working like that. Finally, guys, finally. I freaking knew. I told you guys, I put a lot of effort into this. That's why I've been so bloody pissed off that it hasn't worked. I always said, you know, we've got transistors with more gain, and we've got a VAS circuit that supplies, instead of 1 milliamp, 4 milliamps currently, so bias is going to be a problem, and yeah, it is. But everything else should have been perfect, and that is why I've been so pissed off. You know, now it's working as designed. You know, I'm happy, because this isn't something I rushed. You know, I mean, I probably annoyed some of you guys with how long I've taken to do it, but there's a good reason for it. I read all this crap the other day whilst I was trying to fix my offset problem on the DIY audio forum. Everyone was saying, oh, don't, the 4 transistor current mirror is like the worst way of doing it. You'll get even worse offset. I hate to be the bearer of bad news, but the whole purpose behind a 4 transistor Wilson current mirror is to get less offset. And so I thought, you know what? No one believes it. I'm going to prove it. So here you go. We've got 68 ohms on each side at the bottom, 47 on the top. What have I got in here? 2K2s. Where are they? 2K2s. So this should be the ultimate. Just make sure that. All right. All right. Let's see what the offset settles down to, hey? And then you tell me if I build good amps or if I build shit amps. I'm going to have to get another meter with more digits. One moment. This is 55,000 count. I've got the HP 34401A as well. But this will do. I mean, need I bother? I've got stuff that's still loose, as you can see. It's fluctuating, but it's right down there. And as you all know, I could install pots there and trim that to get it to 0. So, again, something else I see all the time is people saying that 50 millivolts is okay, 100 millivolts is okay, 20 millivolts is okay. And I've always said that's absolute bullshit. You know, I think no, it should be down in the millivolts to 0. And, you know, once this is finished, I'll trim it to 0. This will be 0. I just wanted to prove that, you know, it's more than doable. So this is nice. Nothing's even warm. Very pleased. Things are just like body temperature warm. Some things are cold, some things are body temperature warm, but yeah, absolutely wonderful. All right, well, let's sort out the bias, because at the moment we're drawing 27 milliamps. Right now, we've got to deduct a few things off of there. Each current source is 4 milliamps, so 4, 8, 12, 16. I don't have any clue why that input stage is drawing current. Should be floating. It must just be charging the bases. Not too sure about that. But I mean, it's floating. It's not connected to anything. I'm sure if I tied the feed back to ground, that will glow the full brightness. And I'm sure it works. Anyway, so let's sort out bias. So the thing, oh shit, that was my load bank that I just built. Fuck. Well, good thing that's a nice solid build, because that didn't do anything to it. We're going to be using that soon. Hey, where's this offset coming from? You know what? You know what I think I'm going to do? Because I did this for this reason. The current mirror transistors, they're right next to each other, so that they can be bonded together. Let me show you something. If I put my finger on both at the same time, or all 4 at the same time, no, they're actually all at equilibrium. That's just the differences in the resistors. They're trimmed down to like 0.5%. It's not perfect. And there's obviously slight differences in the transistors, even though they're almost perfectly matched. And then the rest of the amp, you know, some things are matched within 10 HFE, some within 5. It's not perfect, but it's pretty damn close. So I'm quite happy with that, considering there's absolutely no offset trim, you know. That's exactly what I was aiming for. All right, let's have a look across the bias resistors. Now, bear in mind, there are 2. There are 2 output devices per channel and 2 emitted resistors per channel. Okay, so we've got currently no bias at all. I don't know if I want to just open that up. I reckon it's going to be way too high. I think what I'll do, I'll turn this off. And I'll just short 2 diodes. We'll see what that gives us. Hey, this is quite promising. I've still got no bias. Oh, man, if I don't have to fuck with, sorry, you know, like the bias string diode types and how many there are and what type they are and the resistors and all that, I'll be a happy man. Wow, this is going to work. Okay, let's see what adjustment range I've got. I can fix that easy. I just got to change the resistor there. You know, this thing is almost ready to put together. I've got to turn that off because that's quite a bit. That is through 1.22 ohm resistor. We should be looking at about probably like 16 millivolts or something like that. I've got to do the math on it because there's 2 transistors in parallel and all that, you know, yada, yada, yada. But that's certainly high. So what's the resistor that I changed on here for this? I forget how I made this. Let's see, what have we got here? They look like 10k resistors. Why would I have 10k resistors there? Back to the circuit diagram. There are many diagrams in here. My apologies. I am a busy person. I know it's somewhere. Yeah, that'll do. Damn it. No, that's not going to help. Oh yeah, so 560. Oh, they're 120 ohm resistors. Okay, yeah, that makes more sense. 120 ohms. So what I've got, 120 ohm, 120 ohm, and across that I've got a pot and a 470. Okay. If I short over that 470. What is my adjustment range then? Because that's the resistor that I'm going to have to change to get the bias adjustment in the right region. So that's with the 470 shorted and we've got no bias. Well, that's interesting. It looks basically like if I just put a link where that resistor is, I'm going to be literally in the adjustment range of that pot. It's opening the pot. I might put, I'll put a 100 ohm resistor in there and we'll see what that gives us. Well, this is the happiest I've been all week, I can tell you that, because when I got that offset problem, oh, I had the shits. And I'll tell you what, I felt really bad for Astro 30 too, because he was building an amp and he had an offset problem. And I said to him, trust me, the current mirror works, because he stopped using the current mirror and went to resistors. And I said, no, it works, trust me. And he went back to it and he got it to work. And I've been sitting here with this not working. I know it works. I just felt, you know what I mean? The timing was just bad timing, you know. And I was just like, I was thinking to myself, I hope he's not watching my video thinking, is this guy just talking smack to me? If you're watching, no, I'm not talking smack, and here's your proof. It was just impeccably bad timing. Let me just grab a 100 ohm resistor. No, get out. Yeah, you're not allowed in here. I can't just keep removing fur and dirt from the place all the time. I love them. I'll still let them come in every so often to say hello, but I've got to get them out of the habit of being here all the time and playing around in here and all that sort of jazz. Good enough for Australia. You know what? I don't really like... I'm thinking of making these two resistors a smaller value. That way, if the bias, if that pot goes open, the bias can only fall back to, you know, it's the same as when you're making a VB multiplier. You always put the pot down the bottom, not the top, because if the pot goes open and it's in the top, your bias will just go through the roof. But if it's in the bottom, it'll only fall to whatever value it's set by the resistor. You know what I'm trying to say. 120 and 120 gives, what was that current? 56.4. So if I halved that, that would be like 25. Yeah, let's put, why do I even have two? Oh, you know why there's two there? Because in my original design, the signal actually went in the midpoint. I built this amplifier with a Class A amplifier, and it was capacitively coupled to this. It had feedback going into it too, but the output of the Class A stage was capacitively coupled, and the output of the capacitor had a 22k resistor to ground, and it went right into the center point of the diode string. That's how I got the signal into the two bases symmetrically. I know, funny way of doing it. I'll build that amp still. Let's take off both these resistors. They're 120 each. I'll just go get another 100 ohm resistor. And I'll grab a 47 ohm resistor. And you'll see why in a sec. I've already done the math on this. 100 where? Yeah, okay. There it always is, of course. Dumb question. Alright. Because the pot that is there is 500 ohm pot. And I mean, I don't really need a resistor in series with the pot. It's not really going to do anything at all. Just stops you from, I mean, yeah, it does. It stops you from turning it down all the way. All right, yeah, I'll do it all properly. All right. You know what? Let's just tack this on first before I go and form all the legs up. There's no point in me making it all pretty on video. Let's just get this working, and then what I'll do is I'll go off and I'll add all the components that need to be added to it, and do it all neatly, and then come back and then we'll build it, you know, together on camera. So that's 100 ohms, just killing there. Let's see what current that gives. Probably be about 20 milliamps. Jeez. That is nothing. Okay. guess I could be cheeky and use the pot to work out the value. Just as long as that can't come off. Oh, it's limited at half an amp. Let's make our limit 30-ish, 32. Yeah, that's fine. It'll keep running away. It's nowhere near warmed up and in feedback, but it happens quite fast the way I designed this. Right, let's see. I'll demonstrate that in a minute. Let's just get this set first. So this is going to be my fixed resistor value. Yeah, that's what I thought it was going to be. I was literally going to choose that next, but I still thought it would be prudent of me to actually check. All right, one sec. I'm going to have to do... $150. I guess we'll have to do two resistors then. I'll do 75 and 75. 75 and 75. And then I guess in series with the pot, 120. Let's give that a go. 120. Obviously, I'll see what the 275s do first. It's probably going to start at about 40 milliamps. All right, that's the 275s. Let's see what we've got now. Really? Oh, easy. Really? That is still not much. But it is warming up. This seems to be working quite different to when I had it biased with resistors. When I ran 1 milliamp through the diode string with 33 or 39k resistors each side, it settled down and stayed pretty steady, and then the heatsink would slowly warm up, and then the feedback loop would be, oh, it looks like it's, yeah, okay. Yeah. It is slowing down. Well, maybe it's not. Alright, sorry about that. My phone died, but it's only been running for a few minutes. The heatsink is warm. The bias is probably about twice what I want. That's yeah, what, 19 millivolts, 20 millivolts. Say 20 millivolts because not every transistor will be exactly the same. A bit close. There you go, that one's 23 because it's right on the end of the heatsink and it's heating up. Once, because I've only got one channel on, there's 2 transistors right at the end, then 2 transistors close to the middle, so it's not good for thermal, but once both channels are biased, the heatsink will warm up equally and that will stop, you know, some transistors from being hotter than others. Ah, fuck. That fucking had to happen. Sorry, I mean, I think I just blew my amp up. You can excuse my language today. Wait. Really? I guess I only shorted collector to emitter. If something would have popped, it would have popped the other transistor. Okay, I got lucky there. I'm gonna slide this hook in from the other side this time. Yes, that's the safer option. Don't need to measure to ground, I need to measure to the other side of the emitter resistor. So there's, yeah, on the hotter transistor. So yeah, let's just call it 20 millivolts of bias, you know, the average, per transistor. Now that's across a 22.22 ohm resistor. So that's what, 8 milliamps. Well, that's 18 millivolts. Let's call it 20. 1 sec. So 9 milliamps per transistor of bias current right now. Just trying to think. I've not done bias for so long. That feels as hot as it should feel for the entire lot to be biased, in my opinion. So I've got 268 ohm resistors. That's what it ended up being. So for what I would like the bias to be the maximum current. And as you can see, it stays steady. The diode string actually does work nicely, even at 4 milliamps, which is wonderful. So I will have the 2 resistors there still in series just to make it up. That'll be 68 ohms. Now I need to work out what value to see. What I want to do is I want to be able to drop it by half with the pot. So that's 20. The hell? What? What have I done? Oh, it goes to here. Dumbass. Alright, so with the pot, let me think about this. All the way open. Let's say I put 100 ohms in there. Wait, is the pot all the way open or all the way closed? All the way open. Alright. 100 ohms. 470. Yep. That about halves it with the pot all the way open. I'll take it. So, yeah, all right. 68 ohm resistors and 470 is what it's going to be, and that's the bias sorted. That's everything sorted. I might add an offset pot. If I do, it's going to be a fairly high value pot. I'll probably put the 473 back in here, you know. Who knows? I might leave it out. We'll see. We'll see how we go. You got to understand the heatsink's not thermally equally loaded, so that's probably going to affect offset a little bit too, because, well, you know, one side, NPN side, is hotter than this side because this has got heatsink either side of those two transistors. Those two transistors are right on the end of the heatsink, so they're going to run hotter. But yeah, that's it. The thing's up and running. I'm not going to bore you guys with me trimming these leads up and soldering the 470 back in there. Luckily, I've already got 470s everywhere else, so all I've got to do is put that 470 back in and just change these two back resistors for 68 ohm resistors. And what that means, so let me just turn the power off so that noise goes away. I'll just give you guys another quick look at the offset too. I know you want to know what it's at. So yeah, 10, oh that's AC, sorry. So not even. So it's hovering around 10 millivolts. There is something going on there. I haven't put a scope on it yet. I don't know if there's oscillation, my compensation's not strong enough, if it's because my input's floating, wires everywhere, power supply. Oh yeah, it's a switching noise from the power supply. Forget about that. It's because I've got a crappy power supply that injects noise. It's a linear supply, but the display circuit, it's a long story. Anyway, well, I guess that concludes this video. I'm going to install that 473 pot back in. And I mean, look, if I just hold it over where it's got to go, you watch the multimeter. Right? You see it goes down. So all I gotta do is install that and turn it a little bit. Look, I'll turn it a little bit and hold it back on here again. See? All right. It's very hard to do this, but you get the point. I think it's my short. Right. Just goes to the rail. Yeah, so I'll install the pot. Do I want the pot on that side or the other side? Hold on a sec. Yeah, that side. So yeah, I'll install the pots, the 268 ohm resistors, the 147. Make this all right, so now it works perfectly. It'll have zero offset and a perfectly adjustable bias that can't run away if the pot goes open. Once that's done, I got a delivery today, a delivery yesterday, and I should have another delivery tomorrow. And I'll just give you a little demonstration of what some of the parts are. So, remember I did some testing of ESR on capacitors, and I found that the red drop CBB style were really good, but the only ones I had were 400 volt. I've got 100 volt ones. So I've got, in here there's 104s, 220 nano, 100 nano, and 10 nano. The 10 nanos are for the snubbers on the rectifier bridges, so I can take my 400 volt ones back and put them in the box because they're just way too big. I was just using what I had, but I decided to order everything. These Mylar caps, these have, you know, ESR of like 90, 100 ohms, something like that, at like 100 hertz. Maybe, no, I think this is like hundreds of kilo ohms, or like 80k or something. I can't remember. It's up there, maybe 8k. These are down in the ohms. That's why I've chosen them. So these will be replacing those Mylar caps. I have got the 47 microfarad. Where are they? Might have to pause the video for a sec. My apologies. I swear I think I know where everything is, and I do not. Okay. I got the proper 47 microfarad 100 volt Nichicon caps to replace those Chinese ones. So that, like I said, I want to see the difference between 100 nano base suckers on the output transistor or output transistors, and 10 nano on the pre-drivers compared to 1 microfarad on the output and 100 nano there. So I got the 1 mics, MKP4s of course, I wouldn't get anything less. Tomorrow we've got polystyrene capacitors rocking up, all different values like 10 picofarad, 100 picofarad, 82 picofarad, 150, 220, so I can play around the 2-pole output inclusive compensation network. Those other MKPs that I was telling you about have arrived, so I can now show you the 3 choices that I've got. If I want to put that bias capacitor, the 4.7 microfarad, if I want it to be MKP, these are my options that I've been able to find. It looks like the yellow one's going to be the smallest, so that is probably going to get changed with that. I mean, look, I'm overdoing everything else. I'm going to just do everything. There's no point in spending a whole load of money and trying to build the most beautiful amp that you can build. Alright, sorry about that. My phone died. I thought I had it plugged in. The cable's just dangling next to it. So the Nichicon Muse series bipolar 100 mic 25 volt caps have arrived as well, that I'm going to be comparing against these. And the copper foil, copper leaded MKTs that I was telling you about arrived too. So all the fancy stuff to completely finish kitting out this amplifier has arrived. And I'll be honest with you, there's probably other things that I'm just not even thinking about right now that I've also got. So yeah, I'm in a very happy mood. Finally, this is working. I can finally put this crap away and just work on this. I'm going to end the video here because, like I said, I'm not going to bore you guys watching me solder. You've already seen it working. You know I can trim the offset to 0. It's already basically at 0. Everything's nice and balanced. The bias is working. What more do you want? So, yeah. Thanks for watching, everyone. I'll see you all soon. And please give us a like and a sub. I'm really trying to build a channel. Thanks, guys.